Hello and welcome to another developer deep dive. So this time around, we're going to be taking a look at the idea of making configurable systems. And in particular, what I'm talking about here is separating our data from our level. Because, it's great to have, we can easily set up stuff in our level. We can even set up separate levels, which can be a really effective approach. But it's really great if we can start to pull some of our data out of our level. There's a number of advantages with doing that. One of the key things is being able to easily share that data across multiple levels. It allows us to better parallel up the development processes there, and that someone can be tuning data and other people can be modifying the level, keeps our level size down, our level complexity down. It makes it easy for us to have multiple sets of data that we can easily switch in and out for testing or for different configurations or behaviors of things. So being able to separate our data from our level is a really great approach. It has a lot of benefits there, and in particular, if we're wanting a project to be able to scale up, it's something that makes that process significantly easier. So there's a few different ways that we can do that. So one of the methods that we can use is something called scriptable objects. So scriptable objects are an asset. And I want to show you how we can actually start doing some working with those. So let's begin as we generally do with our folders. Now, because we're going to have some data, I'm actually going to set up a data folder. So what I'm going to do initially under scripts is I'm going to create a script, and this might be our level config scriptable object. Now and this is a personal stylistic thing, when I'm setting up scriptable objects, I make it that the names of them always have SO as the suffix. I do that purely as a stylistic thing to make it easy to differentiate between is this a scriptable object versus not, just quickly based on the name. It's not something that you have to do, it's something that's a personal preference of mine. So, okay, cool, we've created the script. Now there's a couple of changes we need to make though. So when we're working with a scriptable object, rather than it being based off of mono behavior, it's now actually based off of scriptable object. And we don't have a start or an update. So mono behavior has start and update, but scriptable object doesn't. Scriptable object is just based off of Unity's very base object thing. So we can create instances of a scriptable object, but we can't, they don't have support for things like update, stuff like of that. Because scriptable objects don't exist at a level. So we've got the scriptable object here. We can do a lot of our similar stuff where we could be, for content, we could be having things be serialized field. I find with scriptable objects, depends on how I'm working with them, because we can have code and logic embedded within them. If we do that, then we could certainly be using things where they're serialized fields, stuff like of that. But often I will just have ones where the variables are public. So let's just say we have some arbitrary parameters here. Maybe we're going to have a HP scale. So it might be the hit point scale for a particular level or something like of that. But we can just have some settings there. So that's cool. We've got our scriptable object. There need to be assets. We need to be able to create them. So to do that, there is an attribute, create asset menu, which will mean that this thing will have an entry under the create asset menu. To work out what things go there then what we can see is an easy way to tell this if the autocomplete is not being helpful. We can see that, okay, it's got things for a file name, a menu name, stuff like of that. So what we can then do is, okay, create asset menu. So the first thing is going to be the file name. So we can say the file name. So this is when we create one of these, what the default file name is going to be. So it's going to be level config. We can then control the menu that it's going to be going under. So I usually would group these. So the way this works is if you do a /, you're creating a submenu. So I could have demo, and if I had multiple scriptable objects that all started with demo and then a /, they'll all go under that submenu. Let's say level config. So that should then mean that here in data, I can actually start to set up these level configs. So if I go to create, demo, level config. So this could be level 1 config. I could create some copies of that. I could have a level 2 config that has a different hit point scale. So we can create this data. We can refer to that. We can access that, which is super handy. So that's pretty useful. That's a cool sort of setup. What if we wanted to have further information than this? What if we wanted, scriptable objects linking to other scriptable objects? Well, we can do that. So let's set up a script here. Now I'm going to set up so that we have, maybe for a level we have a spawner config scriptable object. So spawner config, same thing. It's based off of scriptable object. Needs the create asset menu. Has to have the file name. Spawner config. Menu, again, is under demo. Spawner config. So we could again have something we've got here. Max spawn points is 50, for example. Could have a spawn interval. These are just arbitrary bits of data I'm setting up. So spawn interval might be every 30 seconds. Then our level config could have a list of these spawner configs. So it would allow me to easily then set up. I could have a whole bunch of different ones. So this is where I would start probably grouping these. So I would have levels. We might do, I could have separate folder for the different levels. I could also then set up a folder for the spawners, which again, with this, I could set up, okay, well, I'm going to have a spawner for, let's say, NPC spawner. And then I can just be linking that into these. So I can add in a spawner. It'll let me pick that particular one. So easy for us to start to set up and link data. Makes it really straightforward for working with in a project. So we've got all that data configured, but then we want to use that in the actual game. We need to have something that's making use of this. So we could have then for example, a level manager that we might create an empty object in the scene that is our level manager and give it our script, which we can then just link. So this is where I'd go back to using serialize field, and we can just link that to our level config so that we now have a level manager can access that data, and it's no different to accessing data on another class. So we can just say, well, this happens to be level 1 that we're in. And I'll even rename it level 1. And it's just referring to that config. Means that we can easily swap out stuff. So, and that was what I was saying was one of the big advantages of this. So we could swap out to a config that might be a debug config that only spawns particular type of characters that are causing an issue, or that changes the balance so that it might be super challenging or super easy to progress through. So really easy for us to be able to customize this stuff and do cool and useful things with it. So okay, we can be doing that. But we might be wondering, well, what happens if this level manager changes something in that config? Because it's referring to our level 1 config, which has the HP scale. So what happens if we try and change it? Well, let's find out. So config HP scale is equal to 50. Let's see what actually happens, because we have seen previously when we were working with materials, if we changed a material while it was running, it actually did modify it. It was a permanent change. So let's find out if scriptable objects behave the same way. And there's a lot of different types of data that we work with in Unity, so it's good to experiment. So we can see HP scale did change, but does it remain if after we stop? And it does. So this is something we need to be conscious of, that changing a scriptable object while we are playing will actually cause changes. So if we change any serialized value in a SO at runtime, the asset is changed. E.g. a public or serialize field tagged variable. So that is something that we need to be wary of, that we want to, if we make changes while it's running, it will actually change those if those are ones that it's actually serializing, that it's saving and loading. But we might have cases where we want to put logic in here, where we might want to store temporary data. And we can do that. So there's a couple of ways we can store temporary information. One of the easiest ways of storing temporary data is if we just have the variables not be indicated as being public or serialized field. So for example, we could have here num active spawners. This would not be serialized. So we could make changes to that inside our level config and it wouldn't remember it. So for example, if I set up a public function, it needs to be public so we can access it outside of here. Attempt to change variable. So what I would do is old value is that. And then I would say num active spawners equals 50. Log out the new value so we know that internally it has changed. So that will confirm for us that internally it has changed. And then we will be able to see if that actually gets remembered across it being run. Because that's the key thing. What we want is to be able to have data there that doesn't actually get changed, so we can store temporary information in it. It can be really useful. So we can see it did change it from 0 to 50 while it's running, but the key thing is when we run it again, we should see 0, 50. Now it has actually remembered it, because some stuff, even if we think it's not going to be getting serialized, kind of can. So we need to be a little bit cautious about this stuff. So we can take a step further and we can say system non-serialized to make sure data is not being saved. Because sometimes, just because a variable we've made it private doesn't mean that it's actually not going to get saved. So now we run it, starts at 0, goes to 50, run it again, and it's being consistent. So this force the variable to not be serialized. So just because something is private does not mean we can assume that it will not get serialized. Sometimes it does get picked up and will still get actually serialized there. The advantage of doing a system.non-serialized is that even if we make this public, which can be really handy for us being able to access it externally, even if we make it public, we should expect it to not actually get saved. So we'll be able to confirm that. So we see 0, 50 as expected. Stop it, and then we run it again. And we're still seeing 0, 50. So in a scriptable object, if you're wanting to ensure for certain that data is not actually getting serialized, then you want to explicitly mark it as system.non-serialized. That's going to be the safest way of working with it. Now, okay, scriptable objects are great for storing data. Really handy for storing data. And they're a really effective method for that. The challenge with some of this stuff, though, can be sometimes it's useful to store more complex data. And what I mean by that is, and we'll see this in the, if you've seen the advanced deep dive in procedural generation, we might have data where one thing is inherited from another. So, for example, in the context of the procedural generation, we might have a base class for anything that can modify terrain. And then we have things that inherit from that to do the specific tasks, the specific functions that they follow. Now, setting that up with a scriptable object is not trivial. Theoretically possible. With some custom stuff in inspectors and things like that, we can get that effect, where what we are able to do is we can easily configure in the inspector custom modifiers, but it isn't trivial to do that. And there are actually easier ways of doing that that still give us a lot of the benefits we get from scriptable objects. So one of the things that we can make use of is this idea of something called a prefab. So where we normally are used to using prefabs is, and I'm going to set up another scene for this. This is going to be prefab demo. I'm also going to create another folder here for prefabs. So prefabs are an incredibly useful thing. We mostly encounter them using them for working with visual assets. So for example, if I set up my ground, then one of the things that I could do is I could, okay, I want to make a really simple, basic tree. So I'm going to set up my cylinder. This, I'm going to make it taller. Bring this up to there. That's pretty decent. Actually, I might make that a narrower trunk. So there we go. I've got the trunk. I can then set up a sphere that is going to be the leaves, which I'm going to parent to that to make it nice and easy to work with. Position it up around there. And that probably needs to be a bit bigger. So there we go. That's a very, very simple looking tree. I'll set up some materials for it just for completeness. And so this would be something where, well, I've created this once. I don't want to have to go and, create it many different times. I want to just be able to reuse this all over the place. So that's where prefabs come in really handy. And we'll see using them for this purpose and then also using them for a more data-driven purpose, for which they also work really nicely. So there we go, really basic tree. Going to create an empty game object for holding the tree as well, just to make it easy for placing it. So I've got my tree. I want to create lots of these. So one method is I could just duplicate that and then move them wherever. But then that gets messy if I wanted to have, attach some logic onto all of them now, or if I wanted to make a fix to all of them. So making changes to all of them then is really painful. But if I turn this tree into a prefab, so the way I do that is I drag the parent object that I want to turn into a prefab down into the assets. And you'll see it's created the asset here, and you'll see it changes to blue here. That means it's become a prefab. And now when I clone this, you'll see all of the clones are still blue in the inspector there. So they're still a different color. I've moved them around, so we've got a bit of a cluster of them like that. And what this means is if I change these objects a bit, maybe I decide, actually those leaves, I'm not too happy with the size of those, or maybe the positioning. I actually want to bring those leaves down a little bit. I want the leaves to start more at 0.75. So fix that on one of them. So one of them has got that change. If I want to make it applied to all of them, I can select the top level thing in the prefab. If I come here to overrides, I can see that it's telling me, yep, the transform for leaves was changed. And I can either choose to revert it, so return it back to the exact setup in the prefab, or I can choose to apply it to that prefab. And when I do that, everything else based on that prefab changes. The exception would be if I'd already modified one of these. So if I took this one and put that to, maybe this entire prefab, I've shrunk it. Maybe I've shrunk the entire prefab like of that. And then if I went and changed this one back, and then overrides apply all, you can see it changes slightly. So it does change its position, but the other changes remain. So if we've gone and customized particular aspects of a prefab, then those don't go and change. And we can see it's highlighting in bold. And it can be a little hard to see, but the bolded ones are the things that are different from the actual prefab setup. So really handy for stuff like this. We can really easily place a lot of things, and then if we find a mistake in it, we can then go and fix it. We use prefabs for things like if we're launching projectiles, we'll have a prefab for that projectile. If we're spawning anything in the world, we are almost always doing that via prefab because it gives us something that is there as an asset that we can refer to. And again, it's about pulling data out of the level that doesn't need to be in there. So prefabs are a way that we can do that. And as well as us using them for stuff like this, we can use prefabs for storing data. And the process of working with them is fairly similar. So what we could be doing is, okay, well, this is my prefab demo one, and I've got my scene here. I'm going to set up a bunch of different scripts. So I'm going to set up a spawn manager. So that's going to be the overall thing for controlling spawning. Then I'm going to set up a spawnable base object. Actually, let's go for base spawnable. So for anything that can be spawned in the world, it will inherit from this. And then I'm going to set up one final one, that is tree spawnable. So I'm going to be doing a lot of different layers of prefab stuff here, but let's get set up. So we have create empty spawn manager. Bring that in over to the center. It's a manager object, so it doesn't really matter its positioning, but I just like to have them positioned in the center like that. So, okay, I want my spawn manager to have a list of the things that can be spawned. So all of the spawnables. So because I'm going to be using inheritance, I'm going to have a list of base spawnables. And this is going to be the spawnables. That's what I'm going to call that. Then my tree spawnable, I want to make sure that is coming off of the base one. And what I want to have is think about, okay, well, what are some particular properties here? Well, base spawnable, that I think is going to hold the list of the actual prefabs to spawn, because that's a common thing. If we're spawning something, there's going to be prefabs. So that is going to be the library of things that we can spawn from, or candidates, or our palette. Actually, palette is a good word for it. So that's our available range of spawnable things. And then the trees could have specific customization for that. So the trees could be able to control things like, okay, well, for a tree, I might want to apply some scaling changes to it. So it might have some stuff here where, okay, the height variation. And I might allow the height to vary by 10%. Actually, maybe that's just the entire scale variation. So, okay, that's pretty cool. Base spawnable, might also give it the amount of things to spawn. Maybe just default to 5. So the idea here is we have these configurations that will control what we can actually spawn. So this is where I would put these, rather than being under the prefabs folder, I'd put these under the data folder. And I could set up here, so okay, I have and we just can create a prefab, tree spawnable. And so my tree spawnable, I can add my tree spawnable script, and I can add in my prefab for my tree, like that. So I've got my tree set up here. I'm going to be spawning 5 of them, and I've just set this up as its own separate prefab here. Then the spawn manager can link to that tree spawnable. So because this inherits off of a base class, it's able to link to it. Okay, so I've got my spawn manager set up. I've got my spawnables. So what I can then do is my spawn manager on start. I'm going to go through each of the spawnables in spawnables. And then I'm going to say that it will have a function perform spawning. So this is an approach I like to follow with setting up code, as I write the code to use something before I write the implementation of it. I find that tends to result in a lot less rewriting of things and means that I'm building from a point of how I'm using it, which I usually have a good understanding of that. And I usually find that I then identify better the data that I actually need in those cases. So perform the spawning. So my base spawnable, I want this to have a perform spawning. So this one won't actually do anything. I'm going to instead have this be in the tree one. So let's override that, because then what this can do is, okay, well, it can already access the number of ones here to spawn. So it can access the number of ones here to spawn. So what I could be doing is for and spawned is 0. Num spawned is less than num to spawn, which if I have a look at the number to spawn, I made that private. So I need to make these two protected so that the child class can access them. So the num to spawn. And then what I want to do is I want to pick a prefab. So our prefab is, I can take my palette, random range, 0, palette, count. And then I'll be able to random dot range. And then I can instantiate that. So let's say game object, instantiate, give it the prefab. I give it a spawn location. So what I'm going to say is the spawn location is new vector 3, random range. And then we might say that these are also in the base class. So serialize field, spawn range, I might say 10. Because then what I can do is up to from minus spawn range to spawn range. I only want a 0 value for y. Don't really want the trees spawning up in the middle of the air. And then can do the same for z. So, okay, I've got a spawn location. Rotation, I'm just going to, with these trees, they're symmetrical, so we're not going to notice if they're rotated. So we can have them be spawned in the world. Game object, new tree. Because what I want to also then do with the new tree is new tree local scale. So it's transform.local scale because I wanted to have that variation in scale. That is going to be a vector 3, 1 multiplied by a random range from minus scale variation to scale variation, which I add 1 to. What that will do is, because scale variation goes from minus 0.1, so this will give me a random number from minus 0.1 to 0.1. So it means I'm getting a number here that will be from 0.9 to 1.1. So it'll either scale it up or scale it down. So this is randomizing the scale. Instantiate tree. Pick a random tree. And we are picking a random spawn location. So we've got random tree, random spawn location. That looks pretty solid. We should get a lot of trees spawning, and they should be all different scales, but let's find out. That's going to run, and we did get a bunch of trees, and we can see they are different scales within the range. They're at different locations. So this is another way of, this idea of having configurable things, of pulling data out of a level. We have spawners in the level that then spawn things based on prefabs. And that, again, allows us to have something where we configure one thing. By changing my spawner here, I can go from, I don't want 5 of them, I want there to be 25. And then run that, and then I'll immediately get many more trees. The scale variation, I might not be happy with that. I might be, okay, no, I want a lot of scale variation. I want some really small trees, I want some gigantic trees. And so we get that variation. We pretty rapidly start to get something that's like, if I was on the ground here, this kind of looks not too bad for sort of a very basic, quick little foresty environment. And again, by splitting the data out of the level, we make it that I don't need to mess with the level to change and balance things. People can be working in parallel, which when we're working on larger projects is really important. Also means that if we get a really nice setup with the spawning here, we can easily use that in other levels. Or if we want to create a variation of it, we can duplicate it, we can create a variant of the prefab to help hold that information. So we've got a few different ways of how we can work with data and bringing it out of our level. So recapping a bit, we want to pull data out of our level to allow folks to work in parallel, to allow easy sharing of data between different levels, to allow having easy variations on data. So it makes our lives easier if we pull data out of our level. We have a couple of different ways of doing that. One method is using scriptable objects. Scriptable objects are great for holding data. So for holding information like, well, here's the attributes for a character. Here is the settings for this particular environment. So holding information is something that scriptable objects are excellent for. They are assets. We need to be careful if we are modifying them at runtime. Much like a material, making changes at runtime will persist unless, to avoid that, we want to mark things as non-serialized. Even private variables, unless they are marked as non-serialized, there is a reasonable likelihood that they will get serialized, as we were seeing happen. So when we're working with scriptable objects, they hold data, but we need to be cautious about making changes to them at runtime. If we're doing that, we need to understand that we might need to be flagging the variables differently. But they're great for holding data, and we can easily set them up, easily link them to things just as normal variables. So really great setup. The other approach that we have for working with things is this idea of prefabs. So we can use prefabs from a visual point of view, which we use them a lot for stuff like of that. We create an asset and we set up a prefab for that asset. So we can place many of it, and then if we find an error with one, we just fix the prefab and everything else gets fixed up. We can use prefabs for things like a user interface, the heads-up display, stuff like that. So we can easily add that into an environment. So prefabs are great for creating Lego pieces for a level, things that we can use as building blocks to then more rapidly and more safely and reliably build up a level, and in a way that makes it easy for us to maintain. But prefabs, we can also use them for being able to configure information and to configure stuff in a way that we can't always do with a scriptable object. With a scriptable object, if we wanted to attach on a lot of different things that are different classes, that gets tricky and messy there a bit with it. But we can do that very easily with things like prefabs, where with prefabs, we can just be attaching a component onto them. And as we saw with the idea of our spawnables, our tree spawnable, we just attached a script onto it. So it allows us to work with this information and to have this idea of data that we can be pulling from, but it lets us do it where we can just attach different components onto things. So the same approach that we did here with the spawn manager, being able to have a list of a base class, we can do that with scriptable objects. But the advantage we get with a prefab is a scriptable object can only be one script. It can link to multiple other things, but we only, on that actual asset, it only holds one script. But a prefab can hold multiple. So it means that with a prefab, we can have multiple different scripts there, which allows us a few more options. So in terms of how we decide what we were using, if we are just using simple data, if we're storing information, whether we've got inheritance or not, then we can use scriptable objects with that, providing we are fine with the setup being where one asset has one script on it. It might link to multiple other scripts, but it does only contain one script. Then a scriptable object is the way to go with that. Prefabs, we can use them if we want to be able to support having multiple scripts on something, and we want the order of those scripts to matter. Now, we can still achieve that in a way with a scriptable object, but it requires customized inspector stuff. With a prefab, we just have multiple components that we can attach on. As we saw here, I could have other spawnable scripts attached on. I could have different scripts there. I could achieve the same thing with a scriptable object, but I would need a lot of extra customization in the inspector. So that's the general stuff I would say. The scriptable objects for simple data where it's self-contained, it can be linking to other things, but where you just need a single script. Prefabs for any visual or any element that's used in multiple times in a level or across multiple levels, or if you're needing to have a single object have multiple scripts on it and use data from multiple scripts, then a prefab is going to work better for that. Example I gave there was for the idea of terrain generation. I will tend to there use a prefab that has each modifier for the terrain. So it might have, okay, well, first it's going to do some smoothing of the terrain, then it's going to generate some noise, then it's going to generate this. And I want them to be occurring in a different order, and I might want to easily change that order. If I use a prefab, it's just multiple scripts attached onto it, really easy to work with. I could achieve the same thing in a scriptable object, but not without doing a bunch of custom inspector stuff to get the same ease of editing. So they serve different purposes. I use both though in any of the projects I'm working on. So both is absolutely a thing to be appropriately making use of there. Just depends on the circumstances. But dive in, experiment with them, see the kinds of things that you can produce and get up and running there with them. Thanks folks, that is all for this video. If you're looking for the project, you'll be able to find it up on GitHub, and I've put a link to that in the description below. If you've got any feedback, any questions, please chuck in a comment. And if you're looking to find ways to support the channel, chucking in a like or subscribing to the channel is always a big help. If you're looking to go further than that, then I do have a Patreon set up, and any support there is super appreciated. And there's a bunch of different things that you'll get as part of being a patron there. And the big thing is it's going to help me make more cool things like this, which is going to help more people like yourself to be making more games, which is awesome. And that is all for now. Thank you.